Hey everybody, Vegeta FH1 here. Just been thinking, and I kind of need to take this down. Um, how to find the size of the universe? Hmm. Okay, well, basically this is, we can tell the size of our galaxy um, by the rate of expansion from its center. Um, However, the size of the universe, if it's doing the exact same thing, that being expanding and pushing everything apart. Now, here's the thing: if it's pushing things, we can find it. Now, path of least resistance. This works with everything as far as I'm concerned. Uh, let's say we have our solar system, right? Now we don't know if our solar system is growing or shrinking or whatever the fuck, but our galaxy is. Our galaxy is expanding. Because it's expanding, we don't know if it's the center pushing outward or if it's just being pulled apart or whatever. But its path is center outwards. But what if you have another force being, let's say, the center of the universe? Um, if you have the center of the universe pushing back, yes, you have the galaxy expanding, and then it's also being pushed out from the center of the universe. But then you also have our galaxy pushing solar systems towards the center of the universe, but the center of the universe is also pushing it back. So you have these two forces on either side. Now, usually what this would mean would be something would go flat, extremely flat, but I don't expect that to happen in this way. That said, um, we do have ways of detecting the size of the galaxy, at least our galaxy. Um, but what would also help now, the size of the we could detect the center of the universe. Let's just go with that, okay? So that works. We can detect the center of the universe. From there, we can actually detect the size of the universe. At least the the coherent universe, the one that we're in, the one that makes sense, I suppose, to us. How you'd actually do this is, uh, from my knowledge, I'm not entirely sure about this, but we also know um, the location of another galaxy. This helps a metric fuck ton. Um, the way you can actually detect the size of the universe is the rate of expansion of our galaxy relevant, or sorry, in conjunction with the rate and distance of the second galaxy. Um, you can think about that one for a second. I've lost train of thought. Oh my god, I've lost it. I don't fucking believe it. Right. Um, which direction the second galaxy is going in? No, that's to discover the center. We've already discovered the center. Um, because you can't tell up, down, left, or right in space. Shit. What the hell was it? I hate my brain. I really hate my brain. Oh god, right. No. No, it's totally fucking gone. I don't believe it. Right, so we have the center of the galaxy. We've detected where it is, which is actually quite a huge feat. Detecting the size of it, the secondary galaxy, or the second galaxy, its speed and direction. Technically speaking, if the second galaxy was actually closer to the center of the universe than we are, in fact, it wouldn't matter where the fuck we are, but if you have, okay, it's like a gun, okay? The second you pull the trigger on a gun, you have the highest amount of velocity possible for that, let's say, bullet. And the further it gets away from the point of ignition, the slower it gets. Path of least resistance. There's more resistance, therefore it slows down. Now, there's no resistance in space, but what you can tell is if the speed is constant. Now, the second galaxy, if you can tell how fast that galaxy is going away from the center of the universe, if you can tell how fast it's going, if that speed is constant, if it does not move, that means there's no more push behind it. So if it's left the gravitational pull of the center of the universe, then no, there's something wrong with that. No, there's nothing wrong with that. There's no resistance, so it's not going to slow down. But what it is going to do is stay at its constant speed. At the speed it was last influenced by another force. There we go. That makes more sense. That said, there's something I'm forgetting. See, because we only know of a second galaxy, it actually kind of makes it harder to tell where the boundaries are of the universe is. Technically speaking, the universe will have... Sorry. The universe will have actually stopped where its gravitational field ends. Because after that point it can't influence anything. But the multiverse, again, it's trickling down. If you can tell that the center of our universe is actually moving, which you can easily tell by extrapolating. Yeah, we'll go with that. The constant speed of both galaxies, which you can tell our speed from the center of the universe compared to the distance. I can't say rotation because that's going to sound barmy. Um, uh, the speed of our galaxy, shit, would be told by the distance of us from the center of the universe. When I say us, I mean the galaxy, our galaxy. From the distance of the center of the universe and the difference in speed between us and the second galaxy. And now I've completely lost my train of thought of why I was actually talking about that. Because my brain is sick and I'm sick and I'm still fucking dying of this head cold. Point is, if you find the center of the universe, you can tell a lot of different things. Like where the hell we sit compared to what's the name of the second galaxy? I hate calling it the second galaxy. It's Andromeda, isn't it? We're the Milky Way, that's Andromeda. But you can tell the size of the universe by I suppose the size of our galaxy comes into effect. Not by much, but the size of us compared to the size of Andromeda, the distance between the two, the rate of expansion from the center, and our speed away from not only each other, but from the center itself. Now that's going to take a hell of a lot of calculation, but hopefully that would be enough. Also, if we're going to go on the flat plane whole thing where our fucking solar system is on a flat plane, and the flat plane of a galaxy, then why wouldn't it be the same with a universe? Or why should it be different with a universe? So if we're running off that, it's a lot easier to run those calculations in a 2D effect instead of a 3D effect. That being said, if we're going on the universe being a 2D plane as well, which is so fucking wrong, it's unreal. But if we are, let's say you have the center of the galaxy and you have, let's say the Milky Way is closer to the center of the universe than Andromeda, which it's probably the other way around knowing my luck. But the distance, if you can imagine just a sheet of paper with a black dot in the center, a line going straight through it, and on the right side of this center we have us, the Milky Way, and right next to that to the right, again, is Andromeda. Taking the distance between the center and us, and the distance between us and Andromeda. If you're marking the speed or the zero acceleration of Andromeda, if it is outside of the gravity well of the center of the universe, then you would times you'd times the distance of both with the amount of bodies from the furthest possible point, which would be Andromeda, and that would be the absolute barrier of the universe. that no, there's something wrong with that, and I can see it. I just can't put it into words. Um, but someone will pick up on that. I know it. I can see it in my head, and if an actual scientist if an actual scientist is listening to this, you'll probably see it yourself. There's something not right with that, but you're the scientist. You tell me, and change anything I'm saying here. And well, no, try not to change it. But if there's something wrong, or you can disprove it, or I've overthought something or underthought something, change it as willy nilly as you like, and hell, fucking use it if you want. If it helps get us more information about out there, I'm happy with that. Um, yeah, that's all I had to take down because that was just a complete brain overload, and I was thinking way too much. It applies to something else that I've been thinking about, which is the whole question of um, life out there in the universe. Which, by the way, if you're a scientist listening to this, there is zero chance, absolute zero chance, that we are the only ones in the universe. Zip, zero, nil. I'll explain that on a later video, hopefully when I'm not sick, so I can get all of my thoughts together and actually put them down correctly. Um, yeah, that's all I needed to talk about. So yeah, see yous.